So I'm hoping that Noah's explanation about the judges story, where like everyone just before lunch is much more receptive to things. Hopefully, I think that was the right way, right? They really want to listen and engage just before lunch, especially when we're running over. Anyway, so text mining and modeling in R. I used to work in the NHS and used R quite a lot. Now use R a little bit less, which meant, and use Python more in my current role, which meant that this slide is really easy. All you do is like load Python inside R, right? No, you don't do that. In fact, this is kind of funny. I realized this morning that's not actually an R package, right? It's reticulate to do Python in R. So sorry. Anyway, it's fine. There's loads of cool things you can do in R. I mean, I think I will talk a little bit about Python versus R, or Python and R, let's say, in doing text modeling, because I think both are useful. I'm going to talk about these things. So text mining, which is basically your sort of exploratory data analysis, down to witchcraft, if you want to get into that kind of stuff. So let's start with the text mining. Counting, weighing, plotting, not doing word clouds. I'm not going to show you how to do that. You can't do that. I don't really know what word clouds are, so let's not talk about it. So anyway, counting. This kind of stuff is great in R. Tidy text is a really easy to use package, and often just when you've got like unstructured data like text, just counting stuff is really, really insightful. So yeah, I also noticed as I was redoing it, I was like, oh wow, this count line at the bottom there, that's like, there's this Python aesthetic thing of like, it should be Pythonic. To me, that's like super Pythonic. So that's nice. So I downloaded President Trump's tweets to do this, just because I was looking for an interesting data set and I was bored of Brexit. So we can count stuff. Most of these are kind of fairly obvious, apart from the fact that I didn't clean the ampersand, which is why amp is the most common word. We can, instead of just counting words, you can count bigrams. Again, you can just see there that that's all just built in and like it's really nicely abstracted. You can use this separate functions from the tidyr package, and it just all, I don't know, it's just really nice. So this is a little bit more interesting. I mean, it tells us the story that we can already expect. So I mean, this is the whole thing, right? I mean, you basically don't need to know anything else. Just turn off. But yeah, I mean, that's great. I guess I was hoping that like that would come out, and it did. So cool. Interestingly, American people does make it into the top 20, but I didn't have enough slides for that. You can do more interesting stuff than counting. So TF-IDF is a standard way of saying, let's downweight words which are maybe just super common across a whole bunch of documents. Now, I've already done a little bit of cleaning, so pulled out some stop words like the and so on and so forth. But there may still be ones like fake, which we don't want to downweight because he talks about it all the time, fake news. TF-IDF is one way to do that, and tidy text makes this pretty easy as well. What's nice in a way is that, so there's also a book called, I think it's called Tidy Text Mining by Julia Silge and David Robinson, who wrote this package. And they kind of show, it shows very kind of upfront exactly how these kind of metrics and things are calculated, which is also nice because it means you learn kind of what you're doing as you're doing it. So here you're basically saying, like I say, downweight things which are common across a whole bunch of documents. It doesn't work massively well with tweet data because they're super short documents, so you don't really get big counts of certain words within short documents. But anyway, it's there. You get some different numbers here. I mean, this wasn't massively insightful, and I got a lot of duplicates. But that's because I was doing it quickly. And then you can do some plotting as well. This visualize bigrams actually is a function which I wrote, which uses like graph under the hood. But you can get some things like this. Again, this one's not super insightful because we haven't got enough words. A lot of this stuff is lifted from the tidy text mining book. But here this is just looking at like connections of pairs of words and trying to sort of plot them together. So if you had longer documents, then you can start to see some kind of more interesting patterns. Maybe it's a way of like visualizing topics, but there's other ways of doing that. That's all I have to say about that. Just use a bar chart really. The disappointing thing is I did a couple of talks at the NHS about text mining stuff, and I sat down like loads of things like we can do topic modelling, we can do some like interesting, save loads of time with like classification. There was one slide that my colleague had put in on a word cloud. We get to the end of this big conversation, those word clouds, and you're just like no, just stop. Anyway, so topic modelling. This is something which is interesting. It's kind of a little bit of a pet passion. The idea is that it's an unsupervised technique that you say, given that you have like large collections of words, can you, in what ways can you say that there's some kind of themes coming through based on like the words? So you might think of this as like a clustering technique in some ways. LSA, which is latent semantic analysis, uses kind of a matrix reduction, feature reduction kind of technique to do this. Latent Dirichlet allocation, LDA, is a kind of a clustering process. It uses like Gibbs sampling to say look at counts of words which occur commonly together within a document, and then try and you have to set some features as to how many topics you think they are, but it's kind of interesting. And STM builds on that to also take in like other kind of metadata. So maybe you've got some kind of questionnaire, other information as well as some free text. So you can look at covariates, which is not text, to try and structure that a little bit better. Often you'll see when you're looking at R to do this, like TM, which I've seen described as like the grandfather of topic modeling within R. It kind of breaks all the time, and I haven't found it that useful. Text-to-vec is something that I really like to use with this, but I was interested in the talk, Yelena's talk about the crazy ecosystem of different packages. I think some of the kind of text stuff, certainly tidy text, seem to be trying to approach that and bridge that by not only incorporating different things, but giving you ways of getting the right input for these other models, so looking at that. But interestingly, the author of Text-to-vec seems to be kind of like a Maverick guy who really doesn't like the whole tidy world. So that's interesting if you want to get into R package politics. But it's a great package, so cool. So Text-to-vec works in like a super different way to the whole tidy text paradigm. It uses a lot of like S6 objects, and it's interesting. I mean, he's really into optimization. So one of his blog posts is like doing logistic regression on a 100 gigabyte data set on my laptop. So he's, that's cool. And sometimes you do have to deal with, like, obviously, you're counting all of the words in lots of documents. That's helpful to be efficient. This just gives you an idea of what the code does. I'm not going to talk through it massively, but at the bottom here, this DTM is a document term matrix. So what you're saying is, for kind of a count for each document, we want to kind of just, it's almost like a big one-hot encoding thing. So for each term across all of our documents, let's put a count of how many times that word occurs within that document. This is the vectorization of all of our documents. And once you get to this, in this case it's in some kind of matrix, you can then fit this LDA model. I specified, okay, I think there's 5 topics within Trump's tweets, and then you can fit it and see what happens. And then you can look at, it's basically, like I say, looking at co-occurrences of words across documents and trying to say, well, these words seem to come up a lot together. I mean, I'm kind of not really doing it service here, but anyway, it's an interesting because it's unsupervised way of getting some different insight into it. And there is a kind of a really nice integration with something called LDA Viz, which does have like an R. It does have a Python integration now, but it started in R. And what this does is it allows you, because the question really with LDA is how do you decide how many topics there are within a data set? So what you can do nicely here is, because there's some different metrics to try and decide that, but it's difficult to interpret them sometimes, and that's one of the challenges with this topic modeling stuff. Like, what we're coming up with is a statistical way to describe something which is not really statistical at all. So LDA Viz is a great way of playing about with different numbers of topics and seeing if they still make sense. So you get some idea of kind of like what words are most representative, and you can scale this in different ways. It looks really nice, so maybe it can like offset the word clouds thing because this looks really cool as well. And yeah, you can. It kind of, there's a whole lot of stuff in just in this visualization here, which I think is really interesting. So. I didn't try actually looking at like different numbers of topics, so So I can't tell you how interpretable these are right now, but it's worth looking at. And text effect does integrate with it, which is cool. So what we've got, so we've done unsupervised, part one. The other part, has anyone seen these word vectors stuff? A few people. So this is kind of like the headline of word vectors, is that you can find representations of words within a bunch of documents. You kind of come up with some kind of vectorization embedding, which allows you to do vector compositions, and you can do things like literally with vector algebra, king minus man plus woman, and you see what vectors within your space are similar to that, and you do get queen out, which is super cool. So there's some really nice explanations, and I stole this diagram from the morning paper, which if you haven't seen is a great blog. Word embeddings kind of were around a little bit before this, but Thomas Mikolov, who works at Facebook now, or certainly has done for the last few years, kind of really brought this to the fore, because he kind of came up with a really fast way of doing this. So when you're looking at, say, Wikipedia-sized data sets, you need a fast way to do this. You can do it, and he used, so that's word2vec, was his method to do this. There's another one called Glove, which is so word2vec uses the kind of very shallow neural network, and Glove uses a form of just matrix factorization. You can download pre-trained word embeddings from really big data sets and just use them, and that's often what you're doing, a modeling pipeline. Text effect does this with your data set. You can also do it in tidy text manually, because you can just do the actual matrix factorizations. There's different ways to do it. So Julia Sills has a blog on it, which is cool. So word embedding is nice. You can do things actually one thing that I did was particularly with tweets, short documents, one way to do this is to say, okay, get the word embeddings for all of your words, and then you can represent the tweets using an average word vector, and then you can see similar tweets. You can say, well, this tweet is a little bit like this, that kind of thing. So they're fun and interesting. I think we've had a great talk actually on just classification within R already. The main thing to do that within text, the text space, is just how do you get it into a vector representation, because then any algorithm that you're going to pick out of tidy models or whatever it is applies. The main ways are this bag of words idea, which is counts of all the words that you've seen across all documents for each word. That's bag of words. Or you could just use a TF-IDF representation, so that's, instead of counts, it's this weighted version. You can also use embedding, and so we've had a talk about those kind of things. I like MLR. I think it comes up maybe specifically a little bit more in, I used it in the text setting, because that's often a multi-label classification problem, and I don't know whether tidy models provides a multi-label classification wrapper, but that's certainly something that's a pain to do by hand. So if you're looking to do multi-label stuff, then try and find a good wrapper for it. MLR is one of those. And finally, a few thoughts on neural networks. My only experience, I'm actually going to start at the bottom here, so my only experience of doing that was just playing around with it in R a little bit. And someone might have more experience of this more recently, but my experience was that R, to use Keras in R, you need to install Python, and so you've got a layer, so you've got R sitting on Python, sitting on C underneath. One of the things which I think was a bug for a while in R Keras was that, certainly some of it is that Python is 0 indexed, whereas R is 1 indexed. So, I mean, already you're just feeling uncomfortable. You're like, no, I just can't do this. By the time you get to this point, I would say just Python and R. I mean, there's a Francis Chollet's book. He wrote Keras. There's deep learning in R. It seems like it's people have been spending a lot of time to do this and kind of integrate that stuff. There's lots of interesting things you can do. So Google's most recent pre-trained model, BERT, has been kind of breaking a bunch of the new state-of-the-art records. It seems like this last year or so has been a kind of maybe an ImageNet moment for NLP stuff, where you're getting a whole new bunch of really great pre-trained models, which you can just add a layer on the end and it can solve all of your classification problems, which is really interesting. So that's loads of kind of transfer learning type opportunities there. There are things you can do word embeddings, you can do you know, also your basic kind of neural network designs within R using RKOS, which is great. So word embeddings plus convolutional neural networks is a nice one. But yeah, my feeling is if by the time you're getting to this point, you know, you probably want to be flexible in both. And yeah, that's about all I've got. So we'll stop there for questions.
Anyone have any questions for Tom?